All right, good afternoon. Okay, so today let's look at a bit of problem solving using the graph of speed against time. Okay, now previously what we saw was when you have this kind of graph, there are actually two things we can interpret from the graph. Number one is acceleration of the moving particle, and number two is the distance traveled by the particle. Okay, now how do I look for these two things, these two quantities? Okay, so now let's say we use this graph OA. Okay, currently what I'm looking for is I need to find my acceleration first. Okay, acceleration here is actually denoted by the gradient of the line OA. So let's say I'm looking at the acceleration of the particle at OA. So this is what I'm looking for. So meaning to find my acceleration, this is actually, I'm just looking at OA. So here my coordinate is 360, and of course this one is 0, 0. Okay, so my acceleration will be 60 minus 0 over 3 minus 0. So actually 60 over 3, which is actually 20 meters per second per second. So that's my acceleration at OA. All right. Okay. Now when we are talking about from A to B, we notice it's a straight line here. Horizontal line means there's no gradient. It means here my A is actually 0 meters per second per second. Okay, and let's say you're talking about BC, from B to C. Okay, so gradient from B to C, or my acceleration of BC is, okay, this one is actually 760. This is 90. Okay, 760 here, 90 here. Okay, so in this case, my acceleration will be 0 minus 60 over 9 minus 7. So this is negative 60 over 2, negative 30 meters per second per second. Okay, so here it shows that my gradient or my acceleration is positive, means the speed is actually increasing. Here 0 means, okay, this will be constant or uniform speed. Okay, here my speed is actually increasing. Okay, here negative, acceleration is negative, means my speed is actually decreasing. Okay, now likewise, let's say we're going to calculate distance. Okay, the distance covered from O to A. So this will actually be distance. We're talking about distance. So here I'm going to use my triangle, formula of a triangle. So this is half base times height. So my base here is 3, my height is 60. So distance travel is actually 90 meters. Okay, so that's the travel. That's the distance traveled by the particle from O to A. It covers about 90 meters. Okay, now from A to B, I'm talking about by distance. Okay, now this is actually a rectangle. So here, 3 to 7. So here I've got 4 hours. And this one is actually 60. So my distance is actually 4 by 60. Yeah? So this is 240 meters. Alright? Okay, lastly, when we're talking about area of part C, so my area or the distance covered is actually half. Okay, that's my base, 7 to 9, which is 2, times the height. Height is 60. So this is actually 60 meters. So that means distance traveled by the particle from O to A is 90 meters. Traveled from B to C, A to B, sorry, 240 meters. And lastly, distance traveled in the last 2 hours from B to C is actually 60 meters. All right. Okay. So basically, this is how we use our speed time graph to actually denote acceleration as well as distance below the graph. All right. So what you can do is, please try exercise 7.2c. Okay, self practice 7.2c. Okay, try these questions after watching the video. Thank you.